Oh, it's for social. I have like the old ones I need for you see me?
Let's scoot over and like. Yeah, do one. Well, what? B plus. What'd you have? Yes. Yeah.
Ready? All right.
Left hand of that.
So, this is one of those times, okay, this is one of those times where I'm going to be doing a lot of the heavy lifting on this, but I really want you to kind of dig in and try to participate in a way that's meaningful, okay? Now, I know it's a little challenging for you guys given your current state as high schoolers, as teenagers, but it's actually kind of interesting enough that I feel like you can give like at least a little bit of effort. Does that seem reasonable?
Yep.
It's a water balloon. Along with foam up with water. I don't need water, I just need a small balloon. I like Anthony's like, listen, if you put air in it, doesn't it negate the fact there's supposed to be a water balloon? I mean, right now it's just a balloon.
Yeah, the balloon now. Yeah. You see it?
Alright. Are you guys ready? So, I used to do this demonstration. I used to do this demonstration where you rub the balloon on your hair and then stick it. Have you ever seen this?
Yeah.
But at some point, I kind of ran out of hair, so I just use this. I use this little bunny fur now. I'm gonna use the bunny fur and then, booyah! What's up now? All right, if you would please draw a picture of the board, and the balloon, and then, and this is the cool part, I want you to draw a force diagram for the balloon. So draw and label a force diagram for the balloon. And remember, the first rule of forces says that if you're going to name the forces on an object, you must name the physical object doing the pushing or the pulling. Draw a force diagram for the balloon, okay? And you must name the physical objects that are doing the pushing and the pulling.
What if you turn the balloon around?
What if you turn the balloon around? Did it help?
Turn it around even more.
Wall. Force diagram? Force diagram. Earth is probably pulling it down. The balloon cannot exert a force on itself. You got one. Nailed it. Come, Mr. Ramsey, I'll get the game, son.
Yes.
All arrows emanate from one dot. All arrows emanate from one. Where's the forces? Draw the force diagram. You got one. Nailed it. You got one. The balloon can't exert a force on itself. The dot is the balloon. The dot is. What's the stack? It has to be a physical object. It has to be a physical object doing the pushing and the pulling. Air?
I don't think they're.
Oh, weird. Wall.
Oh yeah.
It's just gonna go like that.
What are you doing?
What a desk on my table. All right, you guys ready? Science magic. Science magic. Probably not the answer, but I like the effort.
I think I'm gonna be right in front of the camera.
What?
I think I'm being right in front of the camera.
Didn't realize it till I crossed it.
How you finesse my seat?
Damn, bro. You can't see.
All right, you guys ready? So, let's do this. This is not helping. I mean, I need it, but I'll do this second. All right, so give me one. So this dot represents the balloon. This dot represents the balloon. Give me one thing you know for sure is exerting a force. Go. Doing what? All right, Egan says the earth is pulling it down, straight down.
Yeah.
Okay, now this is the entire earth, right? This is the entire earth. We call that the weight. The earth is pulling it down. I absolutely agree. Okay? And you know that because if I just let this go from here, what am I, a Jedi now? I train on Dagobah? Right?
No, it's just magic.
Okay? So it will fall on its own, true? Okay. Now, first of all, before we even start, is this thing accelerating?
No.
No. So what do you know about the forces? They have to be balanced, so you cannot just have this. So what do you know for sure? Okay, there's got to be some, and I think this is somehow some friction, so exerted by the wall, right? There's something keeping it from going, right? So. Okay. Now, my thought is it touching the wall?
Yeah.
Okay, so it somehow has to be touching. No?
What if, like, Kelly said something about electrons?
Yeah.
Yeah.
Who said that?
Josh.
Oh, yeah.
Josh said something about electrons? Well, it's the transitive property of class discussion, right? You know, Josh said it to Kelly, Kelly said it to Calvin, therefore Josh must have said it to Calvin. What were you saying about electrons?
Oh, I was trying to figure out how it was like sticking to the board. So I was like, when you rub the balloon and the fur together, I figured a certain amount of electrons like are on the surface of the balloon, and somehow an outer shell. Outer shell.
Outer shell. Don't we call those valence electrons, right? No. So Josh, you think that has something to do with electrons?
Yeah.
Okay. Is it possible this might have something to do with electrons? Has anyone ever seen an electron?
No.
Oh, BTW, I always thought that an electron microscope was used to see electrons. That is not true.
No.
I mean, that is not an actual thing. You cannot see electrons at all. We just assumed that they're somehow there. Okay. Let's pause on that for a second. Let's pause on that for a second. Is it touching the wall?
Yeah.
So which way is the wall exerting a force on it?
To the right.
To the right. I'm okay with that. Okay, so the wall is somehow pushing it to the right, but our issue is that, what?
It's accelerating to the right, but it's not actually accelerating.
That's right, this would imply that if this is all we had, it would be accelerating to the right. Is it accelerating to the right?
Nope.
No, so what do we need? What's that?
The electron.
So, Anthony says it's the wall, but I don't know, is it the wall?
Electron.
I mean, I just can't like,
The wall
fits your questioning.
well, no, I mean, I just don't understand how, like, if I take this and I put it on the wall, right, nothing happens. The wall is still there.
That's because tennis balls are magical.
Oh, it's the magic tennis ball, or the magic balloon force, I see. Okay, are you a little confused?
Yeah.
At least a little? You're not confused?
I am.
Well, what is it? What's doing the pushing and pulling on that then? Yeah, what'd you say? Yeah, my issue is that, like, I don't understand how the wall is exerting a force here, but the wall doesn't exert a force on anything else. Like, I'm just like, right? It's not. You see my issue?
Yeah.
Okay, let's try to do something. Let's try to bridge this to something that we actually feel like we might understand. Okay?
Rovers.
You know what this is? It's a magnet. Okay? It's a magnet. What I'm going to do is I'm going to come over here and I'm going to put this magnet on the wall. Ooh.
Whoa.
Can you draw a force diagram for the magnet? Do that now. Draw a quick force diagram for the magnet. And let's see if we can. Okay? So what we're going to do is, this is called a bridging. Okay? It's a bridging analogy, and what we're going to try to do is to connect something that we might understand to something that we don't quite yet understand and see if we can't make it work. Does that sound reasonable? Okay? So let's see if we can do that.
What is this?
All right, let's do it. What are the forces on the magnet? What are the forces on the magnet? What do we know for sure? Earth is pulling down. Fantastic. Something else?
Friction.
So it doesn't slide down the wall, true? So there's have to be some frictional force. Okay, so that's the wall. What else? Anything else?
Wall.
Jacob. What else?
Wall.
Is the wall touching it?
Yes.
So which way does it have to push it?
Right.
I'm just gonna watch it.
I know, I'm making you a video.
What?
I know, isn't that so nice?
Seriously?
Yes.
Oh, those
Okay, never mind
Well, I
then.
suppose you probably have like papers, right?
Yeah,
We're playing.
thank you. That's amazing.
Well, let's not jump the conclusion.
No, you are.
Hi, Mrs. Tanner.
What else? There's got to be something else.
Magnetism.
There's got to be something else, right? The forces have to balance. What is it? What?
Magnetic force.
The magic part of it. Now, is there something here? Now, we have a sense. Like, and in fact, what I like about this is if I bring this close, okay, I don't even have to put it all the way on the board before it jumps out of my hand. Is that true?
Yeah.
Like, I can just bring it close, and it'll jump. Yes? If I use the big magnet,
Throw it.
throw it?
Throw it at the
Okay,
board.
let's not throw it. Let's not. Okay. So it's a big scary magnet. If I bring this close, it literally jumps right out of my hand. Okay? Okay? It jumps right out of my hand. Because what do we know about magnetism as a concept? Right? Is it a non-contact force?
Yeah.
It is, right? In fact, we've only dealt with a couple kinds of non-contact forces, right? All right. We know that gravitation, is gravitation a non-contact force? Yeah, because if I throw this marker up, does the Earth pull it down without touching? Yeah, spooky, right? Spooky non-contact force.
What?
What about magnetism?
Yeah.
Now, magnetism is different than gravitation because magnets do two things. Can magnets attract other magnets?
Yes.
Okay. Okay. Magnets will attract other magnets, But they do another thing too. Can they repel other magnets?
Yeah.
They can. I can't do it. It's just gonna
Turn it around.
turn around.
Turn the other magnet around.
It's not that kind of magnet.
Swiffer commercial.
I need a magnet with a face. I need a magnet with a face.
Can you drop us another one?
What's that?
Drop us another one.
Just draw a face on it. So here's what you'll notice. I'm going to bring this magnet close to this one. Oh my lord.
It was like, nope.
Did you see it just spin around?
It was like, nope.
Okay. Woo! Does it clearly exert a non-contact force?
Yes.
All right, so magnets can exert a non-contact force, which is a weird thing. So is it possible that the magnet is pulling the wall outward? And if the magnet pulls the wall out, what does the wall do?